Okay, then I will start. First of all, I would like to thank you all for your availability and welcome everybody to this session today, where we will speak about the traceability along the supply chain, particularly analyzing which are the technological enablers that are going as to allow traceability. First of all, a very quick highlight of our agenda today. We will have a quick introduction from my side, then with Alessandro Fontana from University of Applied Switzerland, we will have a quick introduction of which is the environmental value of traceability. Then we will have Heinz Zeller from HugoBoss that will support us in understanding how blockchain can support traceability inside the fashion sector. And then we have also a contribution from IBM. Gabi Zodik is today with us with the presentation about blockchain, how it enables AI-powered supply chains. We have then two other contributions, one from Paolo D'Elia from DGV, where we will have an interesting use case related to the blockchain, the agri-food supply chain, and then Bernard Elkuch from Modum that will describe us how inside the pharmaceutical sector is instead deployed the traceability to the blockchain. Eventually, we have again a contribution from SUPSI. We have Giacomo Poretti, that is also president of the DTI association that's pushing blockchain adoption in Ticino, that will provide us some insights about the association and about blockchain in general. We will have some minutes also for question and answer later on, and eventually we will close the session in a couple of hours from now. So first of all, I would like to welcome our speakers and thank for your availability again to present in this session. And I wish we will give our audience some interesting insights about a blockchain application for traceability. Well, I will start with a quick introduction about the topic. I am starting with the evolution of consumer behavior. Basically, the consumer behavior is becoming always more demanding. In each sector we are addressing. We need faster lead times. We want transparency and convenience. We want always increase the services. But it is not just a matter of that. Consumers are become also aware of the sustainability, that its decline is in its three main elements. So basically, we want more value for money, of course, but it's not just a matter of costs. It's a matter of taking care also of our environment. So we are always becoming more and more aware of the fact that our supply chains, our fast use of products is making some issues with our environment, and also on the other side of the medal, not just to the environment, but also to our social conditions. So how our workers, our products are realized, and which the values that are behind the production of the stuff. Okay. Also, of course, the products, and in particular for the pharmaceutical, for the agri-food sectors, the product safety and the control on it are become more and more stringent, and of course regulations are say constructing on it are becoming more and more stringent in order to make our products always more traceable, more applying to the rules, and so on and so forth. This leads to certifications that can be voluntary or required by regulations, and this is something that our company has also to take care. Say that we can easily understand how our supply chains become also more complex and complicated also. And if on one side we see the technology that can help us in supporting more complex supply chains, also, we have to say that the supply chain itself is changing with a rapidity, impressive speed that lead basically from several years ago, where the short supply chains were basically local supply chains, to today, where you see in the figure in the bottom part of the page, where, for example, to produce a garment, we can make 3 times the turn of the world. So this opens several issues and needs that today we will see how traceability and in particular the adoption of IoT and blockchain DLT technology can support addressing. Basically, traceability is the possibility of keeping a record of the entire production. So basically the production, the distribution, and in several cases also of the use and the end of life of the products that that we manage, and let's say, which are the main pillars of traceability. Basically, we have the unique identification of products, the logistic units and the locations where the product is passing, the possibility of capture and record the traceability data, manage the links and traceability data retrieval, and also, of course, the traceability data communication to be used along the whole supply network. As I said, IoT and blockchain are, of course, a technology that nowadays is able to support us in this kind of effort, and we will see in the different presentation different ways of addressing this need. But before going more in detail in the, let's say, technical part, I will leave the word to my colleague Alessandro Fontana with an introduction about how traceability is supporting the sustainable behavior. So, Alessandro, I leave you the word with your presentation.
Yes. Thank you, Andrea, for the introduction, and hello, everyone. Welcome to this Visionary Day. Today, I would like to present you a couple of, how to say, hints on the sustainability applied to the supply chain and traceability. So here there is this figure depicting a very broad supply chain with different level of granularity, and I would like to focalize my intervention into main aspects. Okay, the first one is about data acquisition, and the second one is about more related to the communication, okay, related to sustainability and in general, and to sustainability performance more specifically. So starting with the data acquisition part, I would like to try to present you the possible role of the blockchain. And so talking about the sustainability assessment of product and corporate, we have many methodologies nowadays to evaluate the performances of product. Okay, we start with product. So at product level, life cycle assessment is a well acknowledged and also used methodology and tool to assess in details the environmental impacts related to a product. And this methodology is starting from the so-called inventory data, and is meant to translate this data into impacts on the environment. And so what do we mean with the inventory data? Inventory data are data for each process belonging to the life cycle of a product, and we have to retrieve in a quantitative way. This is a very peculiar aspect of life cycle assessment, since it is a quantitative tool, and we have to retrieve all the inputs entering into our processes. Okay, here we have an example, a t-shirt production. We need to gather information about how much energy we use, how much ancillary materials we are using, and how much raw materials. Okay, this is the input side. We have also the output side, and so we need to gather information about how many emissions we are creating into the environment, how many wastes, and how many recyclable materials, okay, are produced. And this vision has to be repeated all along the product life cycle. Okay, here we have a very simplified model of cotton t-shirt life cycle, and we can see that the previous the previous data gathering has to be repeated for each of the processes that we identified. And most of these processes are not related only to the reference company, but they are related to the first tier and second tier, and more in general to the entire supplier. So the whole supply chain is involved in this process. If we move from product level to corporate level, there are other methodologies such as the GRI or the GHG Protocol, so Greenhouse Gases Protocol, that allow us to measure the impacts on, for instance, the greenhouse gases of the company. And again, we can see that we not only have to measure the direct impacts created within the reference company, but we have also to take into account also the upstream of the reference company and the downstream supply chain. So we need to gather data from suppliers, and we need to monitor then the distribution and the use phase also of the product. So there is a huge amount of data needed in order to carry out this analysis. So which are the challenges in data acquisition today? So inventory data influences the quality, the reliability, and the repeatability of the assessment results. And we need primary data, so specific data that are not coming all from databases, since they are the ones assuring the higher level of quality and the adherence to reality. Second point, primary data are directly gathered from production line or from companies' repositories such as ERP, PLM. But talking about companies, again, we have to remember that not only the reference company is involved, but all the supply chain, so also suppliers. And last but not least, as already cited by Andrea in the previous intervention, Industry 4.0 today is able to collect and to manage single equipment and also may concern single lot or the single product. Okay, in this concept and context, blockchain trace data origin and support the reliability and the quality. Okay, this is the possible role of blockchain in sustainability assessment and data acquisition and management. Passing to the second topic I would like to focalize, and so talking about communication. We have many labels of products today, environmental label, sustainability label. We have also declaration reporting at company level, okay? And blockchain, again, can act, is indeed already used and exploited in certificate assurance. Another aspect is related to the certificate trading. So there are indeed, again, few examples today, but this is one of the possible. Carbonix is this company is meant to provide a program named Zero Footprint that is meant to assess the carbon impact of product and services and then balance that impacts with carbon offset. And since this is managed through blockchain, they create also good coins, so coins that are meant to further engage consumer by rewarding them. Okay, so also a rewarding system has been built on this blockchain. Another very important aspect is the traceability of product and components, not only along the supply chain, but also along the whole life cycle of a product. And this is a possible enabler for circular economy. So we have a so-called material passport, or more in general, circularity passport of a product. So we gather information related to the product from the material extraction to the production to the product use. We maintain them in this sort of certificate that can be again managed through the blockchain, so that at the end of life in a circular way, okay, so we are talking at the moment when we decide to reuse it, to dismantle and recycle or partially remanufacture it, we have good information in order to operate and to, how to say, extend the whole lifespan of the product, or at least the lifespan of certain components or material of the product. So as a last vision, what we are doing in SUPSI through our research activities and applied research activities, we are developing a web-based platform for data acquisition along the supply chain that is oriented to life cycle sustainability accounting of both product and processes. This web platform is meant to provide sustainability performance evaluation, which are the possible advantages of the platform. It is Industry 4.0 oriented, so IoT oriented, in order to automatically retrieve data from the supplier. We have an easy and fast data exchange and data assurance thanks to the use of the blockchain. There is the real-time assessment for product components and processes enhancement from the environmental and sustainability point of view more in general. And then the labels and the declaration reporting that are generated by the platform can be exchanged and managed again through the blockchain for the certificate trading. So this is my presentation, okay, and I am available, I think, at the end of the day for questions. Thank you.
Yes, thanks a lot, Alessandro. If there will be questions, I would say that probably we can delay them to the end of the sessions. I would leave now the word to Heinz Zeller from Hugo Boss, that is head of sustainability and logistics. That will provide us with his vision and the vision of the company with respect to sustainability applied to the value chain. So please, Heinz, thank you and welcome.
Thank you, Andrea. Can you see already my slide? Is it on?
Yeah, perfectly.
Okay,
yes.
Perfect. So I start with a blank page, which of course I'm gonna then slowly put on some nice topics which is in terms of regulations. Why I start with a blank page is if we talk about transparency and traceability and we look to value chain, I think we have always to remind that we have a lot of regulations in place since probably 100 or more years. And I have not put them on my next slides because I want just to remember important regulations are coming from the ILO, which are, I think, about now 100 years old, or the UN, the human rights, the core conventions. And all these very old regulations, still today, we are facing big problems in really putting them in place. So just a reason, probably all of you heard about the Uyghur issue in China, where not only in fashion, but also in automotive and other industries, there are big cases now where, especially, of course, people start to wonder why still we have forced labor in our supply chains. Interestingly is that, again, with strong regulations like the ILO forced labor is in place, should be respected. Interestingly, only one country react now for a few products. Typically, who was it? It was our Trump administration who put a ban on cotton. The question is Trump now a fan of human rights and labor issues, or is again here the issue about just market protection, because the USA has, of course, a very strong cotton sector themselves. So the question is a little bit, again, value chains and regulations, they are all in place, they are rather old, but they are probably maybe thought of single issues that means internally of a company. But now I start to show you a little bit what actually is coming here really strongly in place. And all what you can see now is going beyond. That means taking a multinational enterprise like we are, but they are all around, also in all the other sectors, that starts, let's say, with a typical the UN guiding principle on business and human rights, which more or less laid the base for all the others that are coming since then. That means this is really a basic Bible, which already clearly indicates what are, let's say, the business duties for working with partners in a supply chain. What was done specifically for the garment sector, the OECD defined the due diligence guidance for supply chains that look into garment and the footwear sector. Also, this one is out since some years. I'm going there nearly every year to see what's new. Still, the problem is that we can put this in place mainly for the first year. So what you have seen from Alessandro is what we have done as well, is life cycle assessments you can do on some specific supply chains, but at the moment nobody is really capable to get to all his cotton farms. And the cotton farms, be it for environment, be it for human rights, be it for a lot of other topics, vary enormously from one to another. So what we normally have, our average data are but we do not have it for a single product, the specific environmental, nor we do have it for, let's say, the social area. What we have then in place, and that's really strong, is the Modern Slavery Act in the UK. This is in place in 2015. But again, you have seen in the UK, they should have reacted immediately to the Chinese case with the Uyghur, because in the Modern Slavery Act clearly described no forced labor, even more stuff in this legislation, but still I didn't heard anything from the UK to ban Chinese cotton, especially the one in Xinjiang where we have the Uyghurs. So the thing is in place, but seems for some reason it's not put in place. And the same is in the California Transparency Act. Also, this is now taken up by Trump, but it's not. I think there is specifically about being good with the Uyghurs. That there is probably more, and that's, sorry if I'm here rather clear. More probably it's in place a clear protection of the own cotton. We have in Germany the Lieferkettengesetz that's being now put together, and why it's coming, because in Germany, you probably heard in textile we have the so-called Partnership for Sustainable Textile, and again we have all the pieces there available, but we cannot impose it. So now, of course, what you do, you create a second law to impose it. But again, as we have the Modern Slavery Act, as we have the other ones, if you don't get the transparency and traceability, all these laws are nice, and we will not bring an improvement. In Switzerland, you probably know it, the Konzernverantwortung. I'm sorry, I don't know how it's in English, but this is the soon a votation we have to go for. Again, this would be in Switzerland, of course, a law that will have an impact on multinational corporation. What we have at the level of the EU is this traceability of sustainable value chains that's driven by the UNECE, and there is also included in this International Trade Center. I'm personally working with them to support them, to give them insights on the fashion business. So you see there is a lot of laws and initiatives and others in place, but without transparency, we will not be able to improve this significantly. When we go to the next, and that's, I hope we all agree, and if not, then we can stop the presentation now, because then it will get really complicated. That's a simplified supply chain of a cotton value chain, which at the end of the day, here probably it's a wool suit, but let's imagine it's a cotton suit. So you see, we have these simple steps, but it gets again complicated even if you put it at these simple steps, because we have tons of certification, nicely outlined also by the preceders of my speech here. And here to get really an overview of what is in is rather difficult. And below what you can see, there is a report. I all invite you to have a look to it. It's called the Fashion Transparency Index. And what is seen that normally brands or retailers, there are only a few, and Hugo Boss is one of them. They disclose 100% of their direct business partners. If you go a layer beyond and beyond and beyond, the question mark is probably the biggest certification you get, because really it's really difficult to get further on. So what we do, for example, and that was a big help for us now in this question with the Uyghurs, we normally ask once a year in advance, before something happens, where is your origin of cotton? So to at least the country, so we are prepared in case something happens, because cotton is still a hot topic. We have a lot of topics still with child and forced labor, like now happened in the Xinjiang region. At least we know from where it comes, and we can reduce, let's say, our impact on the products. But again, I think we rather alone with such in detail questions we do with our suppliers. But you see, even so simple, put it down, it's get really complicated with certificates, and there are even a few more. When you now look at the typical supply chain, and here I concentrate myself on a supply chain partner, can be one, can be us, can be our, let's say, finished garment maker, can be a fabrics mill, doesn't matter. And you see, any supply chain partner is in a system of many systems. So on one side, you have all the trade systems where you have to put certificate of origins with all the information. You are in an audit system, you are in a quality system, and what was mentioned before, chain of custody system, but you have also logistics systems. And with many partners, you have so-called order management system. And the problem is not one of them is really harmonized. So there is really a huge impact. And I just was looking to our, let's say, simple care label, which if you have once time, have a look to it. It's getting a booklet because every country asks something specific. And this is making, let's say, a supply chain just for one partner already huge complex. And now you want to build up on such a system also transparency system. And if this, and that's really important, if this is not integrated in the order management system, forget it simply. And that's where often when I'm in so-called sustainability talks, I only see people from the sustainability world, but the sustainability world will never really implement these things. You have to go to your procurement. And if it's not for them a day-to-day business, that means they cannot integrate it in their order management system. It's simply just by exception or by making long-run targets like we have, of course, cotton you do as a sourcing targets, and you can work on that. So here it's really important. What we have to look, and that was said before, I mean, definitely we have to go to certification. So our business need to have certifications, but again, they're not harmonized. Single step knows other certification. And of course, we can also not harmonize this because at the end of the day, the market will define which certification will survive. What I think is important that all this exchange of documents, and that's why I think blockchain could play here really an important role, need to be secured exchange. And today we have them typically with EDI, but I think that's probably is where a blockchain could jump in and exchange an EDI data exchange with a blockchain-based exchange to make it secured. And then we get a grip into this world of data exchange. What we need, of course, we have to support different level of details. So also when I see the mono approach at the moment, we have to disclose everything, and all the solutions which are out now today, it's a nice dream that everybody going to disclose everything, but business reality is definitely different. So you have also to look into your trust relation you have with your partners. So probably if I'm new to a business partner, he will not disclose everything directly. So we have to clearly understand that we have to support the level of detail. We have to be supply chain oriented and not product oriented. This is also a big error what I see at the moment. If you have to manage products, you have to manage millions of products. If you have to manage supply chains, you can reduce it probably to maybe a few hundred if you take the full complexity. So one of your business partners probably behind has again 5 to 10 to 20, and this one again, so you can reduce it. But if you go to product level, it's a complexity that you will never be able to manage. So go away from product oriented transparency to supply chain oriented transparency. Definitely what we have to look for, what existing standards are out there, and there are a lot existing, and we should not create other ones. So the UNEC works very closely also with CFACT standards. So CFACT has a lot of really good standards. It's out there. EBITS, which is a let's say it's an application of the CFACT into the garment business. Then we have GS1, also widely implemented in the supply chain but mainly on product level, not so much on supply chain level. And what is also important, I mean, you can store anything in a blockchain, but again, here, what we have is garbage in, garbage out. So if I store something in blockchain without any guarantee that this is true, I just forward a garbage, and many people think because it's stored in blockchain, it's the truth, but it's just an information that is stored on a blockchain. So here we need clear guarantee with mechanism we already have in business that this is not garbage, this is a true information. Another thing is, and that's also probably lacking already today with the systems we have, they're not open source. And of course, everybody wants to protect his business, but you probably see in other areas, typically now in software, open source gets the biggest acceptance. Just look at Android. Is the biggest system you have on mobile phones. It's an open source. So you have to do money with other things than protecting the software and not making access to it. And again, with IoT, that's one thing, but I think we have to integrate those other technologies to make this system work. So really an open approach to a lot of different systems to make this happen. And here, that's again a rather simple thing, but also what I can see today is we store things in blockchain and they're there forever. But my problem at the end of the supply chain is not that I have stored it once, I need to be updated. So if something happened in a cotton value chain and I'm not automatically updated, that's nice, it's there, but I'm missing this proactive approach. And also there, of course, I have to have it for me. I don't need it what's around in the world. Anyway, I mean, we are living in a world of information overkill, and we can do this on and on. So I need exactly this blue line for me, because I have to know what's happening in this blue line. And that's, I think, is important. And having a blockchain which you have smart contract, you can trigger information. So you could use these triggers to forward information to me, which exactly I need to make the right decision. What we also have to look, and that's exactly if you want to gain access in this world, we have to look to all the existing systems out there that we can feed them with the information we have. So there is, for example, the GOTS system in textile, and again, they have information. So if we can feed them, we make a big step ahead. Or if we can create automatically of the information we have, a bill of lading, secure it, and connect it with existing logistics system, which probably already some are on a blockchain, that would be an advantage. And of course, what I said again, the ability of disclosing the level of details, that's absolutely crucial, especially if you're working and the cotton farmer is never knowing that he at the end of the day will provide information to me, because we do not know each other. And probably I will know first cotton farmer before he knows that he delivered cotton to a boss and also to a customer. And of course, we need different versions, because in fashion, if you think we're working normally on 4 or more collections parallel, what is in the shop, what is in production, what is in creation, what is at the early beginning. So we need all to have this history, otherwise also we lose control. And again, by visualizing, I mean, we always need to have the up-to-date information to know what's going on in my latest tier, so in 4 tiers, which could be a cotton farmer, and this must be visualized, especially in fashion. If you can't visualize it, forget to start to program it. So for me, important, blockchain is not equal to a supply chain, and that's really how I mean it, because what I see today is mainly in the world of so-called blockchain-based solution. They take the thing, a fiber, I'm going to follow a fiber to its end product, and this is probably most close to blockchain logic, but that's not how fashion works. So you can't scale up this, and that's exactly I'm looking nearly not every day, but a lot in existing solution, and not one at the moment you can really scale. They all have a niche market, and the niche market is extremely small, or simply I do a pilot, and with this I try to get on the market. Doesn't work, doesn't definitely work. So at the moment, there's no solution out which I can say, could go to my CEO and say, gonna buy it. I definitely do not see one of them. What's existing today are proprietary solutions, which is mainly in the hands of service providers or initiatives like GeoTest, like Textile Exchange, or even SGS has solutions, but they're really proprietary system and mainly monoclaim oriented. And this is also not helping us because, as you have seen, we have to collect all these claims, and then we have to decide what we're going to use for our customers or for our stakeholders to make the transparency happening. Again, what I said, I still believe, and I'm in this DLT world since now nearly 3-4 years, I still believe the technology has a huge potential, but what we have to put on it, we have to put an adequate concept, because blockchain is expensive, is not really fast to compare to other systems, but has huge additional topics, which I think is unique to blockchain, but I haven't seen yet a real concept that really addresses the benefits. At the moment, we just store something in this database and say that's why it's there, trusted. This will not work, and it will not be scalable. Interoperability already today, for example, looking into the mineral extraction, there exist a lot of this solution. They already have problem with interoperability, so everybody comes with his own. And again, we will not have the opportunity to scale it. And when you can't scale it, it will be expensive. And if it's expensive in fashion, it will not succeed. Because if you look at farmers, how much they earn for cotton, if you ask them to pay now a transaction on a blockchain, they simply say, thank you, was nice, but we are looking for something else. And again, to the last point, which I just mentioned, we really have to look in cost-benefit ratio. And this is more than ever important. I think with COVID, if you look to fashion, nobody really is happy now to do a big investment for such things. We're all there and hope that we're going to survive this year and go back to something normal maybe in the next 1 to 2 years. And that's reality. So if you want to do something, then we really have to keep in mind costs, investments have to be really, or we can exchange something like a EDI solution, which is costly, and we can come and say, hey, that's a new solution, and will allow you to get into a transparency. And with this, I know that's a huge complexity which stands in front of our sector, but also if you look in other sectors, the complexity is similar. Maybe it's a bit more regulated, and now we have something from food. Food has a big advantage, highly regulated. Textile is still yet not so regulated, and that's why even if you look, for example, to the meat gets all the information to the final consumer. If you want to have the same information which is available at a slaughterhouse, they don't get it or they don't provide it, because simply say the information is not worth the amount you pay for a skin. And that is the problem. So if you cannot find a solution that, for example, can work in the meat industry, which we can take over into fashion, probably we'll always face this, the same discussion. You're not paying enough for getting this information, for having the work done. And so I'm now curious to see what solution will come up, of course.
Thanks a lot, Heinz, for the very interesting presentation. And I wish maybe that the speakers that will take the stage now maybe we will able to address some of the points that you raised in the last slide. So I shift now then to Gabi Zodik, and I'm pleased to introduce him. He is the director for blockchain and IoT platforms from IBM Research. Welcome, Gabi, and thank you for being here.
Thanks. Can you hear me?
Yeah, very well. You can share your screen if you want.
Yes. Let me open it up. Okay.
Okay, perfect. We see your presentation now. Please. Thank you very much.
Okay. Thank you very much. Thank you very much for having me. It's a pleasure. And I'll be happy to take, of course, questions later on or follow up. And what you'll hear in this presentation is really a mix, I guess, of points of view from IBM. And the reason it's a mix, I'll show a little bit our experience in the market in working with customers. We, IBM, are a technology provider, as you know. And I'll certainly try to address some of the challenges just raised in our previous talk by Heinz. And the reason it will be a mix of points of view is I'll talk about things that we see in the market, our experience from running some supply chain networks based on blockchain. And I'll also talk about some of the research activities we have in IBM that are addressing, as I said, some of these challenges and upcoming challenges. I think I don't need to give too much motivation to this audience. And again, I'm taking an example of the food industry where we in IBM have some experience now for running these several years, one of the largest networks. And there are multiple inefficiencies, as you can read through the slide. I'm not going to read them through. I'm sure many of you are aware of those. And it was already mentioned, I think, multiple reasons. One of those that I do want to put more emphasis, I guess, is around, and that's what's also written at the bottom, is around the trust between parties. And when we look at multi-enterprise networks, supply chain networks, oftentimes there is conflicting goals that the partners have. So from one end, there is a good reason for them to share data, to reduce the waste or to improve the efficiency, to make, as we discussed in this example, food, improve the traceability and so on and so forth. On the other hand, and oftentimes they are also competing, or if not necessarily directly competing, they have data that's very sensitive to their business and they're not really willing to share it. In some rare cases, they do share it in one-to-one with one of the partners, but that's obviously not enough. And one of the areas where we are certainly looking to improve is how to, from one end, allow that sharing by creating this trust layer with blockchain so that we can improve and improve the efficiency and reduce all of these issues that we all know. So as I've mentioned, today, many of the networks, if we look from a data point of view, are either one-on-one exchanges that are very inefficient to maintain. If you want some data from a third party, usually there are some intermediates that you need to pass on, which certainly make it much more difficult. If a lot of things are done still manually, that's what we see. And obviously, one of the challenges is that people maintain their own track of transactions and their own records, and then reconciliation often is pretty difficult and takes a lot of time. So yes, and I'll address the point about later on about the quality of data that you put in systems. One of the things, or as I said, trust in its basic form is a very high-level word, but it's based on multiple factors that we can achieve or improve, I would say, with blockchain. And there are multiple qualities, but you can read here examples of the things that we can improve. But really, the fact that we have this distributed ledger that you can write once and have non-repudiation, meaning that you know exactly who wrote the data because everything is signed and cryptographically sound, meaning that once you write a transaction and it's agreed by the consensus, everyone knows where the data came from, and you know the origin and so on and so forth. Non-repudiation is one of those things that improves the trust that you can gain with blockchain networks. Provenance, and I'll get to that in a bit more detail later on, and the traceability that it provides, it's yet another factor. Obviously, when you have a more reliable source of data that you can trust, the fact that it's immutable, auditing and just querying the data becomes much more efficient and much more accurate. If there is a dispute and you need to, as I said, do some reconciliation, it's also very, very efficient. So some of the scenarios, again, or the most common scenarios that we at IBM see, and again, our experience is from running at least a couple very large supply chain logistic networks. One is trade lanes and the other one is food trust. So these are certainly scenarios that we see that are continuously growing with more and more participants joining. We certainly learn and continue to learn and improve and add more capabilities to these basic capabilities that the networks provide, as well as the fact that the demand or the way that these networks would continue and grow varies, meaning that we already see that instead of maybe having one huge network only for food trust, where all of the participants will run, even though they can run privately their own transactions with their own partners, we do see demand in which customers want to run their own networks in their own industry with their own suppliers and providers and so on, and create, I would say, a sub-network that should be part of this bigger ecosystem. I think it was mentioned about the quality of data, so just provenance and the serialization, certainly not only in the food industry, but in the pharma, I think we'll hear more about that also later on, are also very, very important, and so on and so forth. I'll continue and we'll maybe have some time. We'll get back to these scenarios, but essentially these are the scenarios. Again, there are the two big networks we participate, and then there are many more networks in which our services organization is helping companies establish networks. So I'll get a little bit deeper into what we mean by provenance, okay? And I would say that maybe the most basic capability that also was mentioned was really this, and again, these are building blocks in creating that trust layer that I mentioned at the beginning, the fact that we have this network that's immutable and we create more and more transparency, okay? So one of the things that we've seen, and I would say this is the most basic scenario, is just to being able to trace down the origin of goods, whether it's from which farm the vegetables came or fruits, from which factory. So if something happens across the line, then we can know exactly where they are stored. We can go back to the specific stores, specific shelves, maybe if needed, remove them, or just give more visibility and transparency to the end users so they can use their applications, take out the smartphone and understand all the details. And I think, as I said, there are multiple challenges. I think just to mention, not a food industry scenario where we are also active in several pilots is in the pharma, and counterfeiting there is of course a very big challenge, certainly in regions like in Africa, but not only. And I'll address those and how how blockchain can overcome those challenges a little bit later on. But just to dive, before we move on, a little bit deeper into the meaning of what we mean by provenance. So first of all, it's the authenticity, okay? We want to make sure that when we see an asset and a product, we can do an inception and understand exactly, as I said, its originality, that this is indeed the product. Secondly is the traceability that I already mentioned earlier on. And of course, efficiency through this entire process, meaning that we very quickly, as I said, even an end user can go into a store, open up an application, and find and figure out exactly where the origin of a product came from. The data is more structured, obviously, and more analyzable, so that we, as I said, can not only provide the traceability, but with doing more AI while preserving privacy of the data of the individual parties, we can certainly improve the efficiency, but also optimize how these networks work. And I don't have a chart on that, and maybe I should have placed, but it is worthwhile to spend. I mean, so far the industry, we as technology providers spent a lot of time in providing tools for artificial intelligence, for analytics. But in most cases, the assumption was that all the data belongs to a single organization. And we have access to the data and we run some analytics or AI and we can get some insights. In these multi-enterprise networks, the supply chain networks, that's not the case. As I said, each organization keeps the data privately, and there is a chance that if they prevail, if they share the data with everyone in the network, it may hurt their business. So that is really the big challenge that we are facing, we as a research community, I would say now, is how to still enable to run these sophisticated AI algorithms while preserving the privacy of the individual companies. And there are multiple techniques, and some of them are older than blockchain, of course, and are more and are relevant beyond blockchain. Nevertheless, we need to see how we can apply those. And I'm sure you've heard about multi-party computation, zero-knowledge proof. More recently, we're making a lot of advancements in cryptography technology, so homomorphic encryption, which allows us to encrypt data, share it, but still do some level of analytics on top of it while it is encrypted. So not to reveal the data, but only one can reveal the results of the accumulated data of all of the participants. So again, there are multiple such examples of why we need this kind of AI while preserving the privacy. But that's one of the areas where we are investing quite a lot of time. So just to continue, as I've mentioned earlier, one of the systems we've built is named Food Trust. I'm sure most of you already heard, so I'm not going to spend much time on it, but it provides this kind of basic traceability, non-repudiation capabilities, all of the benefits that I've mentioned to being able to trace down very easily products to their origin. One of the challenges, and it was mentioned earlier on, is garbage in, garbage out. And obviously one question is, okay, how can I trust the input that I get into the system? So I gave, for instance, an example of the pharma, in which counterfeit is one of the issues. Because oftentimes the drugs are replaced with fake ones, and it causes huge amounts of mortality. It is in the hundreds of thousands of people annually, because people believe they got the original drug, where in case it's the original drug was stolen, replaced with some fake drug, and no one actually knew. So just deploying a blockchain supply chain solution in which every transaction and all of the data is recorded, and you can trace down from where from the manufacturing all the way to the patient, the fact that the drug went through, if at the end, if somebody in the way replaces the drug, you still record, and if somebody, let's say, used a QR code or something that someone can just copy, it will write it down as a valid transaction, and you can do all the traceability you want, but at the end you still get a copied and not an original authentic drug. One of the directions that can solve such problems is to use various technologies. It's not one way or one technology, crypto anchors. Instead of using a QR code or an RFID tag, which are unique identifiers, but these unique identifiers are something that one can copy, you use some cryptographically device, I would say. So you can think about it as a small RFID with some computing power, as an example, which is cryptographically safe. It has, let's say, a unique identifier that shows and proves that product is the original one. And when you get it, you can validate it. But the thing is, it is encrypted, and nobody can actually copy that. So you encrypt it with a private key, you as the manufacturer for that matter, and then you as the consumer or anyone in the supply chain can use the public key to verify that indeed this is the original item that you get. Obviously, you need multiple kinds of crypto anchors because you need to be able to tag multiple different kinds of products, from very high-end fashion-based products, very expensive, I don't know, fashion-based clothes or things like that, all the way to drugs, to oil, to liquids, and so on and so forth. So these crypto anchors vary. There are multiple companies already manufacturing them. There is no one standard way, but they all share in common that capability, that it protects you and provides you guarantees that what you're seeing is the original device. And now when you integrate this crypto anchor platform, I would say, or mini platform, that can work with multiple providers, and that's something we're actually doing in IBM. You can provide those extra guarantees that the object, the product you're seeing is indeed authentic. And now when you're running this through supply chain and you write down transactions, you can get 100% guarantees that this is the authentic device. Again, the challenge is, and there are, as I said, many companies who manufacture this to reduce the cost, as you already pointed out. If there is a drug that, I don't know, costs a few cents, you cannot put a crypto anchor that costs $1. Make no sense, it will not work. So some of these crypto anchors, like RFID tags and other devices, are extremely, extremely cheap. If it's a few cents or less than that. And again, as I said, there are multiple variations. Some of them are other techniques that, and again, it is a whole lecture to go into that domain. The point is, we are extending platforms such as, you can see the one that I mentioned, so that they can work with these kind of capabilities so that to improve the correctness of data. One more point, or I would say I would continue, and again, to the same point, that we need to make sure that the data we have in these supply chains, whether they are blockchain or not, is indeed correct data. And you can see here, the list is long, and I say I'm kind of running out of time, so I'll go a bit more quickly. There are multiple issues that incorrect data causes. Obviously, if you're relying all your analytics on incorrect data, then all your insights and everything has not much value. We are building, and as we go, we are learning a framework to improve the overall data quality, and we are looking at several scenarios and several industries, both the healthcare industry, but not only. Food is, of course, another So at the high level, we are looking how to reveal these issues and anomalies in the data, or understand how the data is used and so on. Overall, as we move forward, we want to also be able to give feedback of how the data should be improved if the data coming from one participant is wrong or inaccurate or the quality is low, and overall proactively continue to improve the data quality of the entire ecosystem, and provide the correct incentives, as I said earlier, to preserve the privacy. Privacy is the main thing. It's not the only thing, but it's one of the main things while sharing the data. And again, we have multiple of those scenarios. And again, data issues could be as simple things as missing fields in an event that you get, or it could be the case in a supply chain. Certainly, it happens where events arrive at incorrect time. So we can see that already happening, that events not necessarily come with the right timestamp or not at the correct time. And you may get an event that a package, I don't know, left this to a certain source, to a certain destination, when in fact it has not left already. And then you get another event that it only arrived to the previous place and so on. Then, as I said, there is continuous things that a network can do to continuously monitor this data, the quality of the data, and recommend based on historic data, based on additional data that the network has at real time, how to continuously fix even at real time the existing data. All the way to, as I said, when we're looking here at not only technical, but also business level incentivation mechanisms, including at really advanced things as game theory of how to incentivize the partners to share quality data, to invest the extra effort that's required to share with the network so that it will become worthwhile for them to do that. I don't think we have time to get into the details of how we do this, but this is essentially this framework. And again, you could see the charts later on, but it is these ingredients that we are looking at, the validity of the data, the more syntactic things, the completeness of the data, the consistency among events, as I've mentioned, accuracy, freshness, when the data was produced, is it still valid, and the level of confidence associated with that source over time. So these are all the ingredients to provide this data quality. In the last maybe minute, just kind of quickly, and again, I think it was mentioned, but if not, I do want to emphasize, we'll see that there will be more and more of these networks and they will grow. Number of networks, I mean, many of them will be blockchain, not necessarily all of them blockchain. One of the challenges would be to integrate among them. And it's not an easy challenge, it's not an easy task, because these networks provide certain levels of guarantees, all this trust that I've mentioned at the beginning, based on this ledger and the fact that there was a consensus algorithm that agreed on the transaction and so on and so forth, means that when you want to integrate two distinct networks and get and preserve the same level of guarantees, it's no longer a case where you just can invoke an API on some remote service and get some data, because you want the network to provide you with the data and make sure that there is no malicious node in the foreign network that you actually accessed and it gives you some false data. So there is research ongoing in this space, and we are looking already to do some pilots. We are building essentially something called a relay network that really allows to preserve all of the guarantees that these blockchain networks provide, so that you can exchange at the semantic layer data or transfer assets. Assets could be money, could be products, and you can think about scenarios in which in one network you are transferring the ownership of data of a product. Let's say I give you a car in one network, and I need to get some payment in another network, in a financial transaction network. And I want only and only if I get the car and the license, and I get the ownership on the car, only then to transfer the money, and vice versa, only if the money was transferred successfully to change the ownership. So suddenly these two transactions need to behave in an atomic way. So these are kind of the challenges that happen now when you're running multiple of these networks in parallel. And finally, just one more comment. I didn't prepare a slide on that, but because there was mention about the cost and the cost of deploying blockchain networks. So indeed, there is some associated cost when you run these decentralized systems distributed with multiple nodes, each company having their own part of the network. But there are also new directions we are exploring, like blockchain databases, which provide the same capabilities of common ledger, non-repudiation, the provenance and traceability, but they run centralized. So you can think of companies where that are trusted, like for instance, IBM, a technology provider, who would run decentralized for a set of customers. And that reduces complexity of deployment and also the cost in a very significant way. So again, it's something we are exploring as a way forward to reduce cost. And I think I'm out of time already, so I'll stop here. Thank you very much. And again, be happy to follow up on any of these topics and in more detail.
Thank you very much, Gabi, for the interesting presentation. I will say that it's an area, let's say, blockchain is an area where research is still very active. So we have to find the solution even since let's say 6-8 years now that we are working on that. I think we still have some quite maybe not long, but still some activities to do there in order to make them fully available to the industry. The problem of data quality, integrity, and sovereignty is something that is very much researched at the moment. Also, you may know, of course, the efforts that have been doing by the International Data Space Association, also in Europe. So this is something that also in SUPSI we are working on because I think it's one of the central points for companies to address the data and make value from their usage and from their production also. So it's a very important topic. So thank you again for your contribution. And I will shift now to Paolo D'Elia, that is head of engineering in DGV. And we will, hello Paolo, and we will stay a little bit on the agro-food sector. So that also Gabi already talked about. And we have a presentation where we see very interesting application of blockchain there. So please, Paolo, thank you for coming.
Thank you, Andrea. I am Paolo D'Elia from DGS, not DGV. DGS is the name of the company.
Sorry.
Doesn't matter. Today, I'm going to talk about the DGS experience in implementing a blockchain-based application for the agri-food supply chain management. I guess that everyone has heard a lot about blockchain, so I'll focus on why a blockchain is a good solution for an agri-food supply chain, and on some tricks we had to adopt when we deal with security and energy issues. Let's see which are the most important needs of the sector. Efficiency is a real important goal in terms of process monitoring, logistic management, and waste reduction. The traceability is also essential. We have talked about the characteristics that a product must have to obtain, in example, the DOC certification, that is to say, controlled designation of origin. And tracking is also a key feature to implement security and quality check. Imagine that you know that a certain batch of materials is anyway spoiled, and you want to know where every product made with that material is on a shelf, because you want to retire it as soon as possible. then we know that errors or data loss in the supply chain can lead to fraud risk or brand reputation damage on the producer side, and on the customer side to health risk or scam risk. But you know, agri-food chain is very complex, it's hard to manage, and it's hard to monitor. So how can we certify the consistency of every element of the supply chain? We thought that we need a transnational, secure, distributed ledger that is shared by all participants operating within a given chain. And that's why blockchain was our solution. So DGS decided to participate in a larger project financed by the Piedmont region. The main objective of the project was to design and realize a hardware and software platform to identify and measure residues of pharmacologically active molecules in food. The project is named Food Drug Free, and in this project, DGS had the mission to design and implement a blockchain-based supply chain management application. So we selected 3 basic foods, eggs, milk, and honey, and for each one of them, we selected a reference product, pasta for the eggs, torrone, nougat for the honey, and a particular cheese, Piedmont cheese for the milk. The first thing we made was designing a process flow of the products chosen for the project. Then we outlined the workflow in 4 macro steps in order to divide data in a simpler and more comprehensible way: supply, production, packaging, and shipping. In this slide, you can see the eggs chain. In this other slide, we see the milk chain for the production of cheese. As you can see, macro steps are the same, but the second tier steps inside and the data bounded to those steps are different for every product. This is the slide for the honey chain to the production of nougat. But at this point, we had not yet chosen a blockchain technology. But what we already knew was that at every transition between one step and another, we wanted to write a transaction in the blockchain. So we designed the overall system architecture that is strongly data-driven. Data flows coming from the sensors in the factory and are collected by a gateway and sent to the Azure IoT Hub service. Then data are analyzed by Azure Analytics services in order to apply statistic algorithms and to detect any anomalies or values out of defined range. Only the significant data are sent to the blockchain, not all the data, only significant data, and they are sent whenever a lot of products make a transition between one step and another. The results of the analysis are then sent to the presentation interfaces to show some relevant KPIs to customer and producer, and to have an administrative dashboard for the chain managers. During the analysis phase of our projects, we decided to implement a blockchain based on the Ethereum protocol. Why Ethereum? Ethereum is a public blockchain, and this is an added value in a research project, and is currently known as the most popular public blockchain network for decentralized application development and smart contracts. As we will see later in this presentation, smart contracts are really central in our application. The problem was that in a standard Ethereum blockchain, to validate the transaction, the miner node is forced to perform the resolution of very complex algorithm that uses a large amount of resources. That is costly, it's time consuming, it's energy consuming. This consensus algorithm is called proof of work. In this chart, we see the global energy consumption of Ethereum plus Bitcoin blockchains, and we see that they are comparable with the ones of a medium-sized African country. it's really a very large, a huge amount of energy. However, with the implementation of a custom Ethereum blockchain, it's possible to configure during the initialization phase the complexity of the algorithm that must be solved to validate transaction. This parameter is called difficulty, and setting this parameter to very low values greatly simplify the mining process, avoiding excessive consumption of resources by miners. In this chart, we see the fluctuation of energy consumption with the difficulty value. Oh, it's expressed in US household equivalent. We experimented that with a few dozen nodes and a difficulty level set to 1, the global energy consumption per transaction is about 0.4, 0.5 watt per hour. That it's a very low value. It's a value that everyone can face. After we have chosen the blockchain protocol, we choose to work with Java technology. So the technological tools needed are Get, Web3j, and Solidity. Get is the client software that we need to install on our nodes in order to communicate with Ethereum-based blockchain. It's an open source platform. Again, it's an added value for a research project, and it's maintained by the Ethereum community itself, and this ensures compatibility and frequent software updates. Web3j is the Java framework for production of distributed application. The framework offers the possibility of operating with blockchain by deploying transactions, smart contracts, and allows the recovery of information previously added to the blockchain. It also takes part in the creation of smart contract templates in conjunction with the use of Solidity tool. The third and fundamental tool is Solidity. Solidity is a Turing-complete language that is used to create smart contracts. In our application, at every step transition in the product line corresponds a smart contract deployment. So the definition of the contract templates is central. We developed a tool to fully automate the creation of a smart contract template. So once the Solidity definition is written, using Solidity tool and Web3j, we can automatically generate Java classes for the templates. A little talk about security. We all know that blockchains are considered intrinsically safe, but when a blockchain is put in a larger IT architecture, there are a lot of factors that can threaten the system security. So we decided to apply the security by design pattern that is performed in 4 principal steps. Define a global vision of the project, which consists of a data flow diagram, interface design, and functional requirements analysis. Then we have to define the trust boundaries, that is to say, which are the systems that we consider trusted and which not. Then we have to define which threats can affect our system and how we can mitigate the risk of these threats. In this slide, we see a simplified data flow diagram of the system. We saw some slide before. We have to say that all interfaces were implemented via REST API, and that we consider trusted the blockchain itself, the systems, and the line between the IoT hub and the sensor in the farms and the factories. So we focused on external entities and data flows. For the analysis, we used the STRIDE model in which threats are divided in 6 categories: spoofing, tampering, repudiation, information disclosure, denial of services, and elevation of privileges. In the STRIDE per element model, threats are applicable to architectural entity following the schema shown in the table. So because we consider not trusted external entities and data flows, we put the focus on spoofing and repudiation in external entities, and tampering, information disclosure, and denial of services in data flows. How did we deal with these threats? We set up a secure communication channel via SSL TLS, and this gave us protection from spoofing, tampering, information disclosure, and partially for denial of service. Then we set up a client authentication that we implemented by JWT tokens and API keys. The more we choose to deploy our APIs on an API gateway that offers protection from DOS and other known OWASP vulnerabilities. Last but not least, we protect from repudiation by electronic signature of blockchain transaction, obviously. I want to spend a few more words on circular economy concepts and how a blockchain can help to implement them. As we see in the Ellen MacArthur Foundation definition, a circular economy is restorative and regenerative by design and aims to keep products, components, and materials at their highest utility and value at all times. How can this concept apply to food? The idea is that a circular food economy has to start from the correct management of natural and cultural capital and has to involve the highest respect of planetary limits and must end up in a fair space for human society and growth. We can summarize this vision in what we call the 3C schema. The natural and cultural capital that we want to preserve, the cyclicity of materials, energy, and knowledge, and the coevolution of natural and human-made systems. We see in detail how a blockchain can help to this objective. We can certify the conservation of biodiversity through the protected storage of data regarding the origin of raw materials, the quality of the seeds, the races of animals and the seeds used in farms. We can improve cyclicity, monitoring the quantity and quality of waste in every production step, and analyzing how the scraps could be used in other production lines. And we can analyze the packaging process. We can calculate with high precision the CO2 footprint of production. Talking about the coevolution, through the registration of contracts, we can monitor the suppliers, asking them to certify their worker condition and protection. Or in example, we can monitor the steps and we can certify the quality and quantity of water that we take and return in a river, measuring the efficiency. I like to think that these virtuous behaviors certified by the blockchain should be rewarded by countries and governments, for example, with fiscal benefits, so that we can make the world a better place. And then, this positive thing, I'm at the end of my presentation. Thank you for listening.
Thanks a lot, Paolo. Very interesting presentation. First of all, I would say that energy usage for mining is something that it's quite important and can make some challenges in adopting blockchain. In adopting and let's say in exploiting blockchain is something that it's very concerning, and several efforts are being doing in that sector. Also, the very last slides that you presented, so circular economy principles, European Commission is investing a lot in this activity, as you surely know, also with the involvement of DGS in several European projects. I know that you are working on. Of course, the interoperability of platforms, that is something that we saw also from the presentation of Gabi, is something that's at the moment, as in my opinion, to be very much let's say, addressed as all the different system managing data that are then necessary to feed, let's say, the traceability network, let's say, all that need to be active inside the value chain. It's putting some problems in the implementation phase. So all the ERPs, different system that we use, the different technologies. So it's something that at the moment is quite still to be addressed. There are several European projects working on that. There are several activities from industrial domain. So it's something that we have to tackle very much in order to arrive to a solution, I think. So thank you again, Paolo. And I will go for the last industrial presentation. We have Bernard Elkuch from Modum. Bernard, can you hear us? Okay, good. I see already your presentation. Well, welcome on board. Bernard is business developer in Modum. That is a quite new company working in the sector, and they will provide us an interesting use case example based on a pharmaceutical case. So please, Bernard.
Thank you, Andrea. Thank you for having me, and also thank you for the presentations which have been taking place already. Very interesting. Thanks for that. Awesome. A lot is going on in the blockchain space, which is very good. Yeah, Modum is a real blockchain child, I would say. So you might know that the Modum did an ICO back in 2017 and ended that successfully with about $30 million funding. And now in execution of what we have planned so far, developing hardware, developing software, and by using blockchain as a trust layer. I mean, we have heard that by Gabi, which is very interesting. Thanks for that again earlier on. And what we have is kind of a very practical use case, bringing blockchain and IoT together in here in a pharmaceutical use case. I'd like to start with, I think, a quote which is well known, and since it's supply chains, and I think in these current challenging situations and environments, even more supply chains are gonna compete with each other, and not at least because customers, or in the case of the pharma companies, the patients, is on one hand demanding more transparency, and on the other hand, he wants to have, or deserves at the end of the day, an effective and original on time. And therefore, Modum has been founded to help to gather reliable data on an easy way, or to collect that in a trust layer along the supply chain to get or to gain end-to-end visibility for sensitive goods. This is especially for brand owners, but also when it comes to regularity fulfillments, when it comes to what we have heard already, anti-counterfeit topics, product quality topics, and so on. Today there is an existing market out there, so this is nothing new. So we are not reinventing the wheel at all. But there is a lot of, let's say, legacy players out there dealing with solely hardware. So it's purely hardware centric view and products and solutions, so to speak. It's very manual work, which is very error intense and human intense, thus very error intense. And most of the time it's not possible to process this data within other systems. So to even feed in networks, we have heard a lot the word networks, but even to feed it into a traditional ERP system, since it's just a PDF and you have to do some manual work on that. And I think this is kind of the battle a lot of pharma companies or distributors in that way are in, because they have to comply on GXP XP on one hand and do condition monitoring, but on the other hand, it's still not directly connected and fully trustable in an end-to-end view to their core systems. And this is what we try to solve by adding this trust layer on blockchain on one hand and having kind of a holistic view on an end-to-end supply chain for these sensitive goods especially, and bringing, let's say, the real world, because we do not have to forget that with all the blockchain talks I attended the past 4 to 5 years, we always a little bit exclude the reality and the real world. So we have to somehow connect real world problems and real world scenarios with blockchain technology and make it kind of tangible and also usable. So I think it's not possible for mass adoption or for enterprise usage to have kind of command lines stuff. So it has to be in terms of applying the application or a hardware piece or even putting it together. It has to be as easy as using your mobile phone, to my opinion, and you don't even have to recognize that there is any blockchain behind it, because it's just too complex at the end of the day. And this is what we combine. So we combine on one hand the real world, where we have challenges, as you said, that the patient is demanding for instant transparency and an original product. And on one hand, we have regulations as well as evidence and sustainability topics on top of that when it comes to condition monitoring. And with the current situation, or with the current tool set we have seen, it's all a reactive topic. So as soon as you plug your USB logger into your PC, then the data pops off, and then you see there has been a deviation, and then you can start your quality issue. But what is when you forget to put that in and stuff like that? What is when somebody is gonna work on that data and really does some fraud on that data, for example? And this is where the trust layer of blockchain comes into play in that very sensitive topic. And what we do is basically we start with a IoT device. We start to measure the conditions of a shipment in that case, and transmit that into, or transfer that by combining the IoT device with the effective shipment or item. We bring it into the digital world, and having then kind of a hash and data set onto the blockchain. So it is immutably linked between, so the IoT logger and the shipment, or the item is immutably tied to each other and hashed on the blockchain. Then we have a topic like for doing this evidence topic or equality and compliance topic by having proactive possibilities to analyze and bring that at the earliest possible stage to the attention of the quality people, in order to really filter out the shipment which has been, for example, opened or had an instability in temperature or something like that, and get on triggers on that and inform the people in the quality and compliance disciplines proactively about that, in order to really act proactively at the right point of time for these specific shipments, which makes it a holistic process in an end-to-end manner, typically deeply implemented into the IT landscape of our customers, into order management tools, ERP tools, and so on, in order to have the data also available in their tools. Therefore, we have a whole tool or hardware and software set which consists of two loggers. One is a real-time logger, which we have in one use case I will show just in a minute. The other one is a purely small, easy-to-use temperature logger, and then we have a set of software product control towers, maps, and so on integrated into our software solution. It's easy. It's as easy to use as an app on your iPhone. So the only thing you need is your phone, an app, and one of the loggers, and you can store your journey. So for just testing purposes and setting that up, for our customers, it takes maybe an hour to have the first shipment on the road and do this condition monitoring real time, which means there is no effort to really integrate that beforehand into solution before testing that. And I think when it comes to, and I've been spending more than 20 years in software companies selling software to enterprises, and when it comes to fast track deployment of software solutions, I think this is a key point as of today, because as we have heard from at the beginning, there is not a lot of investment willingness as of today for just doing a pilot or whatever it is. So it has to be very easy to use. Coming straight to the point of use cases, we have here 4 use cases. One or two I would like to highlight then, but for example, in Switzerland, all the postmans which deliver a package, or in that case a dispo box from Swiss Post with a pharmaceutical product, have condition monitoring in place as well. They have a logger from Modum, and the system is basically integrated into the core systems of Swiss Post as well as into the handheld. So we enable basically 15,000 postmans every day to collect this data and process this data in order to be compliant for the patient. We have also end-to-end tracking use cases. We come to that in a minute on a separate slide. We have intralogistics use cases, which we reduce typically a lot of manual burdens and the manual work, and then have a kind of a very nice ROI at the end of the day, because there is a lot of hassles related to that. And we have also kind of more asset-based monitoring when, for example, it comes to vehicle monitoring or storage monitoring and all that stuff, which is also crucial, of course, for the product. Having a concrete use case example here from a big pharma corporation, European-based pharma corporation, where we had the challenge of that they want to gain these easy end-to-end transparency on their goods, which were produced in, I think, in Norway or in Sweden, so somewhere in the north, and having basically primary supply chain and secondary supply chain by integrating both pieces of hardware. So on one hand, we had the real-time logger, which at the end gives you transparency where this shipment has been and which conditions in terms of light, in terms of temperature, in terms of humidity, and so on, has been within that shipment during the whole journey of that shipment. And surprisingly, our customer could even see that obviously the logistics company, the truck driver is living somewhere in the Netherlands, and always when it comes to the weekend, he passes to the Netherlands and then come back into Germany. So this is some let's say nice and funny side note, but this is something they were not aware on. And of course, if the truck is the whole weekend somewhere in the Netherlands and it's hot summer, it might be an issue not to do that when it comes to pharmaceutical products at all. So at the end, we applied the whole ModSense portfolio to these use cases. As I said, with real-time loggers, which log then the data and store that data or hash that data into the blockchain. So in the modem use case, we purely use the blockchain layer as a trust layer, which is a typical use case, I would say, and bring these data then into our solution, or as I said, integrate that into solutions from our customers. Another use case which is even coming more and more is the whole topic around clinical trials and the clinical trial supply monitoring. Since this is a very critical part, even it is within it's more an intralogistics topic. It's a very hot topic within the pharma industry. Having in the clinical trial, there is a lot of R&D resources allocated, so a lot of money allocated, and of course, if there is a clinical trial shipment not stored or transported within the right conditions, and there is any deviation within that supply chain, it might be that the whole sample or the whole trial is on risk at that end, and for them or for this specific use case, it's very crucial that the data is reliable and trustable, which is coming from an IoT device in that sense. That's two concrete use cases from our end. Yeah, very short and quick presentation. So I bet the time from the others. We are based in Zurich, and if there is anything to speak or any questions, feel free to reach out.
Thank you very much, Bernard. I would say that it's very interesting how at the end we arrived at a very concrete application of blockchains and IoTs with Modum that actually is basically on the market with a solution that directly address the use of these technologies to support companies in managing their supply chains. Thank you very much for your presentations.
Sure.
I will then give the word for our last presentation to Giacomo Poretti, that is a colleague of us, a senior researcher and lecturer at the Institute for Information Systems of SUPSI, and also today it's president of Ticino Blockchain Association. So I will give Giacomo the word for our last presentation. Please, Giacomo. You are muted.
Correct.
Okay.
Hello, everyone. Also from my side, I hope you see my full screen presentation.
Yeah.
My name is, as Andrea said, is Giacomo Poretti. I'm working as a senior researcher at Institute of Information Technologies and System and Networking at SUPSI. And after these interesting speeches concerning blockchain and supply chain, the objective of my presentation is to present what we are doing here in Ticino in this context, and maybe share some personal point of view as academic researcher concerning blockchain and more in general supply chain. Okay, as you know, Switzerland plays an important role in blockchain development internationally. There are some big entities based in Switzerland, starting from Ethereum from the beginning, and we have actually Libra Foundation that also is moving in Switzerland, as well as many other industries. It's an economy that employs more than 3,000 people. In this context, here in Ticino, we have two academies. We have SUPSI and USI with courses in blockchain and digital currencies, as well as Master of Science in Economics and Banking and Finance. In SUPSI, we have certificates of advanced studies in blockchain and fintech. We notice a growth in companies and startups working in blockchain. We have today monitored more than 30 companies and startups. And inside our academics, we have more than 500 students in IT area. So our job as academics, we have to explain companies and teach companies and how to exploit the blockchain for changing their business. And to the other side, we have to teach our students how to program those systems, and so that they can bring a real advantage to companies once they go out from the school. This is what we name the technology transfer task that we have to accomplish here in Ticino. So what is the blockchain? It's for sure a complex technology. There are a lot of strange words as hash, cryptographic, decentralized protocol, tokens, and we heard before from IBM new concept of crypto anchors and whatever. So it's something that for technician is complex, and for business or people working in the industry is something that make it's impossible to understand. So it's very hard to explain how blockchain works and how blockchain is implemented. And what I also aim to explain to people from the industry, that normally the more a technology is complex, the more the technology can simplify things in the real world. But we have to differentiate the level how we explain to people what blockchain is or what technology is. So it's often said that blockchain is a disruptive technology that will redefine the world, and that is true. But business company and need to do that, to exploit those kind of new technology. Business company need to redefine their process and redesign their computer systems. And so at the end, I always say that technology is ready, but companies are today not ready to exploit this kind of technologies. So going back to supply chain, why is supply chain so related to blockchain? Because it's a technology that enables users to interact using common database and common infrastructure. So it's something that go outside their, as we have to link together different users around the world, it's important to trust in a common infrastructure that is not owned by a single entity. Blockchain is the technology enables to store history of custodian and transformation and trade of assets. This is the main problem to solve of the supply chain. And it's also a technology to run autonomous tasks that enable to automate processes so that it can reduce time and cost in maintaining those kind of solutions. But blockchain, we saw today in the previous presentation, normally has also a lot of problems that need to be solved in a specific way. We already heard that one of the main problems is the garbage in, garbage out concept, that as blockchain is immutable, if I put wrong information in the system, so I get wrong information out of the system. But one of the most problem that has to be explained to all actors working in this area is the granularity of information. So from the business side, the business is run on single element or single instance also of a single item production workflow, and those kind of information are not possible to be tracked in a convenient way and at lower cost and in a reasonable time inside the blockchain. So blockchain solution need to be solved and treated at greeted batches or lots instances, so that we have to move from a instance-based system to batches or also at company level. So to enable to put information in the system that can be treated in a reasonable way. To do that here in Ticino, to solve and to explain those kind of problems to companies and to students and to all people involved in this kind of projects, we built a cluster of academies, companies, startup, and students, also involving lawyers and investors, so to close the gap between companies' needs, technology people, and technology projects, so to enable to develop solutions that can really become marketable products. So at the end, the object is create as much as possible synergies between all actors involved in this ecosystem, so to enable a real technology transfer between education and real economy. And this is for sure not only based on supply chain, but to any kind of other business process, like as finance, public administration, or in general, any kind of digitalization process that need to be optimized. This is my short presentation. I try to reduce the time because we are already late in the program. So I would go back to Andrea for the end of the webinar with the question and answer section. Thank you.
Thank you very much, Giacomo. I wish that the association will pave the way for other collaboration, also maybe with the companies that we had in the panel today, and to grow Ticino as also a cluster of companies and academia that can boost up the blockchain technology and its application in industry. Well, I don't see questions, sorry, in our question and answer panel. So I will take the occasion again to say thank you to all our speakers. It has been a pleasure to host you today in this session, and I think that all the presentations have been extremely interesting and with several viewpoints provided to the audience. So thank you very much all for your participation. And I wish we will have other occasions to discuss, maybe do projects together, and so on and so forth. So thank you all and goodbye. Have a nice evening.
Thank you.
Goodbye.
Thank you, Andrea.
Thank you.
Bye.
Thank
Thanks.
you.
Thank you and goodbye.
Bye bye.